problem 2. So we're told that a radio tower sends out a radio signal with a wavelength of 2 meters. So here's the radio tower, and it's sending out signals, and the wavelength is equal to 2 meters, 2.0 meters, so 2 significant figures. And part A says, what is the speed of radio waves? Well, in order to answer this one, we need to realize that radio waves are just electromagnetic radiation, and all electromagnetic radiation travels with the same speed. So the speed is equal to the speed of light, which is 3.00 times 10 to the 8 meters per second. This is going through air. Air is very close to a vacuum, so light travels at almost the same speed in air as a vacuum. So this is the correct answer. Part B says, how long does it take for the wave to travel 2 kilometers? So we know that time is equal to the distance over the speed. So this is equal to 2 kilometers, which is 2,000 meters, over the speed, which is 3.00 times 10 to the 8. And so this gives us, when we solve it on the calculator, 6.667 times 10 to the minus 6 seconds, which to 2 significant figures is 6.7 times 10 to the minus 6 seconds. We would expect a very small number here because light travels very, very quickly. So it doesn't take light very long to travel a short distance like 2 kilometers. Part C asks, what is the frequency of the wave? Well, to answer this one, we'll need to use our wave speed equation, v is equal to f lambda. We can rearrange this one to get the frequency. The frequency is equal to the speed over the wave over the wavelength. The speed is 3.00 times 10 to the 8, and the wavelength is 2 meters. And so this gives us 1.5 times 10 to the 8 meters per second to 2 significant figures. Part D asks us, what is the period of the wave? Well, the period is equal to 1 over the frequency, the inverse of the frequency. And so the period is 1 over 1.5 times 10 to the 8. And so the period is 1 over 1.5 times 10 to the 8. Whoops, we've got the wrong units here. This should be the units for frequency because it's the frequency we've found. So this should be inverse seconds or hertz, not meters per second. So this is 1 divided by 1.5 times 10 to the 8 hertz. And solving that on the calculator, we get 6.7 times 10 to the minus 9 seconds is the period.